Okay, let's get right into it. For decades, we've been obsessed with the carbon we're adding to the atmosphere. But what if there is another equally massive carbon story that we've been missing? A story that isn't about what we've added, but about what we've taken away from the land itself. This is the number at the very heart of this story: 344 petagrams of carbon. Now, a petagram is a billion metric tons, so yeah, this is a truly mind-boggling figure. It's like a hidden carbon debt humanity has been quietly racking up against the planet's ecosystems. A number that huge is, well, it's kind of hard to wrap your head around, right? To really understand its impact, we first need to dig into where it even comes from. And that brings us to a concept that's absolutely central to this research: the terrestrial carbon deficit. You can think of it as the planet's missing carbon. To put it simply, it's the total amount of carbon that has just vanished from the world's vegetation and soils, all because of how we've used the land. For farming, for forestry, for building our cities. The really crucial thing to get here is that this deficit is the gap between two different worlds. On one side, you have the potential carbon. That's how much carbon Earth's ecosystems could store if we just left them alone. And on the other, the actual carbon they hold today. The deficit is everything that's gone missing in between. And that gap, that 344 petagrams, adds up to a 24% depletion of the Earth's natural land-based carbon stocks. We have removed nearly a quarter of the carbon that our planet's ecosystems would naturally be holding for us. And if you're still trying to get a sense of the scale, get this. This historical debt from land use is on par with all the fossil fuels we burned globally in the last half-century. It's a massive parallel carbon story that's been happening on land. So, if we've lost this much carbon from the land, the next question is pretty obvious, right? What's responsible? Well, the research digs right into the main drivers of this enormous deficit. Looking at this breakdown, you can see three main culprits really pop out. Expanding pastures for livestock is the single biggest driver, making up 30% of the loss. Right on its heels are cropland expansion at 24% and forest management activities at 23%. So yeah, taken together, agriculture and forestry are responsible for the vast majority of this carbon debt. But the story has some interesting regional twists. While grazing land is the top driver around the world, if you zoom into temperate regions, places like Europe or the United States, it's actually the expansion of croplands that becomes the #1 cause of carbon loss. Now we get to what is, for me, the most surprising part of this whole story. You would think a problem this massive would be completely accounted for in our best scientific tools for understanding the climate. I mean, that's a fair assumption, isn't it? If we've managed to lose a quarter of the land's carbon, our most advanced climate models should have that dialed in perfectly. Well, this is where the research reveals a pretty critical blind spot. First, a quick definition. You'll see this term DGVMs, or Dynamic Global Vegetation Models. All you really need to know is that these are the super complex simulations scientists use to model everything from plant growth to carbon cycles. They are absolutely essential for forecasting climate change. And here's the bombshell. The bar on the left shows the carbon deficit that this study found based on real-world observations. The bar on the right shows what the average climate model, the average DGVM, calculates for that exact same deficit. The gap between them is just enormous. So, just how big is that gap? On average, the climate models we rely on for global policy decisions are underestimating the terrestrial carbon deficit by a staggering 37%. They are missing over a third of the historical carbon loss from land use. So why does a modeling error like this matter so much? Well, it's not just an academic detail. This underestimation has profound, real-world consequences for how we plan for our climate future. The implications here are actually huge. It means we've likely underestimated historical emissions, which in turn could shrink our remaining carbon budget for meeting climate targets. It also complicates efforts like reforestation, because if you don't know the land's true potential for storing carbon, you can't plan accurately. It tells us the restoration challenge is far bigger than our models had assumed. To put it as simply as possible, if you don't have an accurate accounting of the debt you've already accumulated, you can't make a reliable plan to balance the books and get to net zero. And that, of course, leaves us with the ultimate question. This research has given us a new, a clearer, and frankly, a more sobering number for our impact on the planet's land. So faced with this massive, newly quantified carbon debt, the challenge for all of us is, how do we even begin to make the deposits to pay it back?